This is the first section of chapter 1 from the FP1 book, and this is the chapter on vectors, and this first section is on the vector product, also known as the cross product as well. So from your core 1 book you would have learnt about the scalar product, and I'll put a link at the bottom. And the scalar product was defined as this, that A, or scalar, or it could be called a dot product as well. That A dot B is equal to the length of A times the length of B, or the modulus of A and the modulus of B, times by the cosine of the angle between A and B. So this is what you've learned in your core 1 lessons. We can also work out something called the vector or cross product. So the vector product or cross product, and you'll see that this is sort of defined in a similar way to the scalar or dot product, and it's A cross B. So I'm going to do it a little bit larger so that you know that this is not a times sign here. So A cross B is equal to the length of A times by the length of B, the length of vector A, the modulus of vector A times by the modulus of vector B, times by the sine of the angle between them, and also multiplied by a vector n, which is a normal vector, and little hat there tells us that it's a unit vector, so it's 1 unit long. This vector n is one that's a normal to vector A and B, so this is perpendicular to A and B. Now you can see it's similar to the dot product, like the sort of way that it's defined looks similar, but there are 1 or 2 differences. The first difference is that when you work out the scalar or dot product, the clues in the name, you get a scalar. You actually get a number. You get a number answer when you work out a dot product. And also it is commutative, which means that A dot B is equal to B dot A. So the order doesn't matter. If you worked out A dot B and you worked out B dot A, you would get the same answer. Okay, so how does that compare to the vector or cross product? Well, I suppose the clue's in the name, in that with this we don't get a scalar, the answer's going to be a vector. So we get a vector as an answer, not a scalar. And also it is not a commutative. I was going to say associative. It's not commutative. In other words, A cross B is not equal to B cross A. So there's some similarities in the sense, some differences. So why is it not commutative? Well, if I were to draw the vectors, sorry about that, so I'm going to attempt to draw some vectors in 3D here. So imagine these laying flat on the ground. This is my vector A here, or sorry, not my vector A, yeah, my vector A here, and this will be my vector B, and I want to find a vector that is perpendicular to both of them, this vector n here, this normal. A cross B, well, the sine of the angle would be measured in this direction. Okay, so the direction of the angle matters. So this would be A cross B. A cross B would be the angle measured from A to B. And the vector which is perpendicular to both of those would be a vector going this way. Okay, so this would be my normal vector and I'd make it a unit long. Okay, however, if my angle, so 3D attempt again here, not sure how good this is going to be. So these are my vectors A and B laying flat like this. But this time, if I did B cross A, I will be measuring the angle in that direction. So just put down here that this is B cross A. Then the normal vector, which is perpendicular to both, would now be going this way. Hope that's sort of clear. Not the greatest diagram, but it shows you why A cross B is not equal to B cross A, because of the direction in which we're measuring the angle. So if we're measuring it, I suppose if we look at the first diagram, in a sort of anti-clockwise direction, then the vector points up, that normal vector that's perpendicular to both. If we're measuring the angle, I suppose in an anti-clockwise direction, the normal vector, which is perpendicular to both, points down. Now this leads to a couple of results. The first result being this, that if we have two vectors, let's map that out. If we've got two vectors here which are parallel, then their cross product is going to be 0. And we'll just explore that in a moment. So if two vectors are parallel, well, I suppose we can explore that now. If they're parallel, then the angle between them is 0, which means we, in the definition for the cross product, we'd end up doing the sine of 0, and the sine of 0 is 0. So the whole product or cross product ends up being 0. So if two vectors are parallel, what will happen if we call those two vectors A and B, then A cross B will equal 0. So that's the first result we get from this. So we'll call these vectors A and B. And secondly, because of the direction which this normal vector points, depending on whether we do A cross B or B cross A, what we can say is that A cross B is going to equal negative B cross A. The negative indicating this normal vector here is pointing in the opposite direction, and if we're pointing in the opposite direction, well, the lengths of B and A are going to be the same, so they're going to be the same here. The angle is going to be the same between them, between these two vectors, but the normal vector here will be pointing in the opposite direction, hence the minus. So because this changes direction, we put the minus here, so we get two results here. If our two vectors A and B are parallel, A cross B is 0, and A cross B is equal to negative B cross A. Okay, let's have a look at this example. So it says find the values of, so the first one we're going to be doing is I cross I. So these are the unit vectors I, j and k. So again, my attempt at drawing something in 3D, you're going to have to use your sort of imagination. So here's I, here's J, and here's K, pointing that way. So we've got to try and imagine these are perpendicular, like this. So something like that. It's meant to be three-dimensional, and also just our definition of the cross product here, because we're going to be using that. So let's make that a bit bigger, so you know it's the cross product, it's not multiplying. So it's the length of A times the length of B times the sine of the angle between them times by this normal vector, which is perpendicular to both. So the little diagram we've done in red is going to help us. Right, so I cross I. So using the formula, what's that going to be? Well, it's the length of I times by the length of I, that's like our A and B, times by the sine of the angle between them. Okay, well, these two things are parallel to each other, so there is no angle between them, sine 0, times by a vector which is perpendicular to both, so this normal vector. Now, the length of I is 1. Now, it actually doesn't matter what we do for this normal vector, because sine 0 is 0, isn't it? So this normal vector doesn't really matter. We're going to end up with 0, which is what we expected, because we said that if two vectors are parallel, and I and I are parallel, their cross product is 0. Now this 0 is a vector. Yeah, so we should underline it. It's the 0 vector. Okay, part B. So J cross K. Okay, so it's going to be the length of J times by the length of K times by the sine of the angle between them. Now I can see from my diagram that J and K are perpendicular, so their angle is 90 degrees, times by the vector which is perpendicular to both. Now what we need to do, because it's J cross K, I'm just going to draw it in purple here. We're going like this. Yeah, that's the direction. J cross K will be measuring the angle in that direction. Now, using the previous diagram that we had about the normal vector, that will mean that the vector which is perpendicular for both, for J cross K, will be I. Okay, this is where we sort of need to almost be able to imagine these types of diagrams in our head. So let's just go back a sec. We've got I or JK like this, so this is J, there's K. We're measuring this angle going from J to K, so that perpendicular vector has to be going in that direction like that, if it matches up with a diagram, which is the vector I. So you need to be sort of fairly good at sort of working out these things in your head, and I is the unit vector as well. So if we work that out, that's basically going to be 1 times by 1 length of J and K times by sine 90. Sine 90 is 1 times by I. So all we are left with is the vector I. Then we'll move on to the last one, I cross K. So that's going to be the length of I times by the length of K times by, well, looking at my diagram at the top, I and K, although it doesn't look it, they are perpendicular. So times by sine 90. Now this is where we need to be careful. If I've got I cross K, which direction is that normal vector going in? So let's try and draw them here. So I and K going like that. So there's I there, there's K. And I cross K will mean that we're measuring this way. Now if I'm measuring that way, the unit vector needs to be pointing in this direction, not the other direction. Okay, it all sort of matches up with the direction of the angle. So that means that actually this normal vector, which is perpendicular to both for I cross K, will be negative J, not J. It will be negative K. If it was K cross I, the other way round, and we were measuring the angle going this way, like this, that would then be the vector k going in that direction. Right, so let's work this out. 1 times by 1 times by sine 90, which is 1, times by negative j. So we get negative j as I cross k. Obviously, if it was k cross I, it would be j, it would be the other way around, or a different sign. Okay, this example is almost like going to be proving how we can, or another way of finding the cross product. So we actually want to do A cross B, and that will be A1, A2, A3 cross B1, B2, B3. Now to help me do this, I'm going to write these in terms of I, J and K. So A1I plus B2J, whoops, not B2, A2J plus A3K, and that's going to be crossed with B1I plus B2J plus B3K. Now the way we're going to do this is use the fact that when we work out the cross product is distributive. It's distributive. Now what that means, and I'm not sure why I put a lowercase I or spelt distributive like that, distributive, not distributive, which means you could think of it like expanding brackets. Expanding brackets we can do because with that algebra it's distributive. Yeah, so basically what that means, to work this out, I'm going to do this cross this plus this cross this plus this cross this plus this cross this. Yeah, so everything joined by a line I'm crossing together, a bit like expanding brackets. Let's go for another colour, and then these here. So you can see I'm going to have 9 sets of crossings to do. So maybe I'll write out the first few, and the rest I will just write out quickly. So if I start with the first ones, I will get A1I cross B1I plus, so it's a bit like expanding brackets, A1I cross B2J plus A1I cross B3K. Right, so I'm going to pause it and then write down the other 6 you'll get. Okay, so this is what we're going to get when we actually distribute this set of cross products. And for each bracket, so if I take that bracket for example, we're going to use our definition of the cross product to work it out. And the cross product was that A cross B is equal to the length of A times the length of B times by the sine of the angle between them times by this normal vector which is perpendicular to them both. Now we just did some work on things which are perpendicular or parallel. So for example, the very first bracket, when I work this out now, A1 and B1 is going to be the length, and in fact in all of these letters here, the A1s, the A2s, the A3s, the B1s, B2 and B3s, these represent the lengths of the vectors, because the I, J and K are unit vectors, so these are going to represent the lengths. So we're going to be multiplying the lengths. The A1, let's say the first one, it'll be A1 times by B1, that's the length, times by the sine of the angle between them, and we already know that if they're parallel then we're going to end up with 0, so it doesn't matter what this normal vector is, it's going to be 0. So what that means is for any brackets where I have I twice, like this one, it's going to be 0. Yeah, what else is going to be 0? I've got j twice, that's going to end up being 0. And there's one other one here, this will end up being 0. So let's work our way through the brackets and see what happens. So let's go to this bracket here and see what that works out to be when we do the definition of the cross product. So it's going to be the length of one vector times the length of the other. So that's just going to be A1 times by A2, or B2, sorry, that's their length. So A1 B2, then times by the sine of the angle between them, well, they're perpendicular, so that's going to get times by sine 90, it's going to get times by 1, so this is times here, not cross. Then times by a vector which is perpendicular to I and j, but it needs to be in the right direction. Now here's a way you can remember what these vectors are. So I'll just do I cross j is equal to k. Now I'm going to show you how you can remember whether they're positive or negative. Notice these are in alphabetical order, I, j and k. Now all I'm going to do is each time just shift the letters across, and they're still going to be positive. They're still going to be in alphabetical order. So I've got I, j and k with sort of I in the first position. If I start with j, so j, k, they're in alphabetical order. So the next letter over here is I, that's the one I haven't used. And then that will leave the last two in alphabetical order, which will be written like this: I, j and k. So I know they're not on the alphabetical order on the left hand side, but I basically did this: I, j, k. I, then go back to the beginning, j, k. See, it sort of cycles around. I, j, k. So think of it like this. From here to here, from here to here, and then from there back to the beginning again, like that. When they're written that way round, then it's always going to be positive. Hopefully that makes some sense. If I show it maybe on the second one, that might make a bit more sense. So we started with I over here, so I, j, k. I, j, k. Yeah, we're basically going from left to right like that, and then when we get to the end, we go back to the beginning. Now, if we write them the other way round, then we'll end up with negatives. So if I start by writing I, j, k like this, it's a negative. Yeah, so notice how I'm basically writing it backwards, starting this way, and then when I get to the end, I'm going to loop back. So the next one, if I move the I, let's say, to this position, I, j, negative k, and then I'll move the I to this position, so I, negative j, k. So that's starting from the other way around. So with this, ijk, 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 positive. Here, ijk, ijk, ijk. Yeah, and hopefully that will help you remember which is which. Now the reason why we did that is because here we need to work out I cross j. So if I go over to here, I cross j is k. So basically the first bracket works out to be A1, B1, K. And we're going to do the same with the other bracket. So if I go on to the next bracket here, which is this one, So obviously the lengths are A1, B1, or A1, B3, sorry. So A1, B3 times by the angle between them, or sine of the angle between them, so that's going to be 1. And then that's going to get times by I cross K. Right, so we go over to our little thing over here. I cross K is going to be negative J. So times this by negative J. And if we simplify that, that's going to be, well, we'll have a minus now. So that will be minus A1 B3 J. So we're going to go through, I'm going to pause it and then go through all the other brackets and write down what they're going to be. Okay, so that's all done. I just need to make one correction. So here I put B1, that should be B2 obviously. So let's just change that to B2. Now what I'm going to do is to collect together all the I terms, all the J terms, all the K terms. So if I collect together the I's and their coefficients, I'll have A2 B3 minus A3 B2 I. Then I'll do the same with the J terms. So I'll have A3 B1 minus A1 B3. Notice how you've got like the same numbers but reversed. So like A3 B1 and then A1 B3. And then the last one with the K's, that will be A1 B2, not B1 as I wrote before, minus A2 B1 K. Now you may or may not recognize this. If you've done matrices, this is what you'd get if you were to work out the determinant of a 3 by 3 matrix where the elements of the matrix are I, J, K, A1, A2, A3, B1, B2 and B3. Now this gives us a nice little way of working out the cross product, and it's in determinant form. So if we take this and we'll say in determinant form, it becomes this. Let's do it in a different colour. So A cross B is equal to basically the determinant of this matrix that has elements I, J, K, A1, A2, A3, and then B1, B2, B3. And hopefully you'll remember how to do that. I'll just do that down here. So you take the first element and you times that by the determinant of its minor. Do you remember the minor? That's what you'd get if you crossed out what was in the row and column of that I. So its minor is going to be this A2, A3, B2, B3. And then remember it's minus the second element times its minor. So let's just get rid of those. And let's work out what its minor is. If we cross out all those elements there in the J row. So that minor would be A1, A3, B1, B3. And then plus the last element times its minor. So again, we'll just work out or highlight the elements in that row and column, and that will leave a minor of A1, A2, B1, B2. Okay, and this definition of the cross product is useful. It's useful to be able to work out the cross product using this alternative method in the same way that you know, we've got an alternative way, an easier way of working out the scalar dot product by just multiplying each of the numbers together rather than working out the length of A, the length of B, and timesing it by the angle between them. Right, so we've been given two vectors here, A and B, and we need to find a cross product. and part A says do it directly. So when we do it directly, we're going to use the fact that the cross product is distributive, which, as I said before, is a bit like expanding brackets. So we pretend we're expanding brackets. So what will that give us? So we've got 2i minus 3j cross 4i plus j minus k. Right, so if we do that, we will get 2i cross 4i plus 2i cross j plus 2i cross negative k plus minus 3j cross 4i plus negative 3j again cross j, and then one more plus negative 3j cross negative k. Right, so remember, if we want to work out the cross product for each one of these brackets, it's going to be a cross b is equal to the length of each of the vectors times by the sine of the angle between them times by this normal vector. Yeah, so we need to work out which direction that's going in, because remember I cross j, for example, is not the same as j cross I. So we need to be careful of that as we're going through. Now the first bracket that we have here, well, they're parallel, aren't they? And we said that the cross product of parallel vectors is 0. So even though the length is 8, length of A times the length of B is going to be 8, 2 times 4. The sine of the angle between them is 0, sine 0 is 0. So the very first bracket just works out to be 0 and the 0 vector, so we should underline it. Moving on to the next one, we multiply the lengths together, so we get 2, so plus 2. Then we need to do the sine of the angle between them. Now all of these brackets, apart from the ones which are parallel, the sine of the angle between them is going to be 90, so we're going to be multiplying by 1. But what we want to get is this normal vector, this n here, so we need to get the right one. So in this we need to work out I cross j, and I cross j is just going to be k. You can always look back at the previous example where we wrote down a list of all the different ones, but I cross j is going to be k, so that just leaves us with 2k. Moving on to the next bracket, this one here. Now I'm actually going to bring the negative out and do 2 times negative 1, so I get negative 2. That means all I need to then work out what I cross k is, and if I work out I cross k, that is going to be minus j. Again, look at the previous example, you'll see that I cross k, because we've taken the negative out, is negative j. So negative j. Moving on to the next one here. Again, I'm going to bring the 3 out. So actually, let's get rid of that plus and put minus there. So it's going to be minus 12, minus 3 times 4. Then I need to work out j cross I. And if I work out j cross I, that's negative k. So negative k. This bracket here, we'll work this out. So negative 3 times by 1, that's going to be negative 3. And then I need to work out j cross j. Well, that's going to be, I didn't spot parallel. It's going to be 0, so there's no point putting minus 3 times 0. Let's just put 0, the 0 vector. And then we'll just move on to the last one here. We'll do negative 3 times by negative k, or negative 1, so that'll give us 3 plus 3. And then we need to work out what j cross k is, because we've taken a negative out, and j cross k is I. Right, so if we simplify that and put everything together, we have 3i. We can forget about the zeros. Then we're going to have plus 2j, because we've got negative and negative, so plus 2j. Then after that, if we look at the k's, I've got plus 2k there, and this is going to become a plus 12k, isn't it? So it's going to be plus 14k. Okay, so that's using the direct method to do it. Now let's do it using the determinant. Let's see if this is any quicker. I suspect it will be. So A cross B is going to be the equivalent of finding the determinant of this matrix. So I, j and k go in the top row, and then we want the coefficients of the A vector. So that's going to be 2, minus 3, 0. Then we want the coefficients of the B vector. So it's going to be 4, 1, minus 1, 4, 1, minus 1. Okay, so I times by the determinant of its minor, which is going to be minus 3, 0, 1, minus 1. Then minus j times by the determinant of its minor, which is going to be 2, 0, let's make sure I get this right, 2, 0, 4, minus 1. And then plus k times by the determinant of its minor, which is going to be 2, negative 3, 4, 1. Right, let's see. Let's work this out, starting with the first one. So this determinant here is going to be 3. 3 times by, negative 3 times by negative 1. Take away nothing. So 3i. Let's go to the next one. So if we work this out, this is going to be negative 2, take away nothing. And then negative 2 times by negative j is going to be plus 2j. And then the last one here, this is going to be 2 minus negative 12, which is basically 2 plus 12, which is going to be 14, plus 14k. Right, can you see? Much quicker. So this is probably the method we're going to be using to work out what the cross product is. So we'll just put a note here that this is quicker than working out directly, which is what we did in part A. So this is probably going to be the method that we're going to be using. Okay, part C says verify that A cross B is perpendicular to both A and B. Right, how do we do that? We do the scalar or dot product. Remember that if you do the scalar or dot product of two vectors, they are perpendicular if their dot product is 0. So we'll just write that down as a reminder. So since A dot B equals 0, if A and B are perpendicular. Let's start with, let's call this vector here, let's call it C. So I'm going to be doing A dot C. What is that? So that's going to be 2 minus 3, 0, that's A. And C is going to be 3, 2, 14. So if we work that out, we'll get this dot here. 6 minus 6 plus 0, 0 times 14. Okay, so it's 0. So A and C are perpendicular. Let's now do B and C. So that's going to be 4, 1, negative 1 dot this 3 to 14. So that's going to be 12 plus 2 minus 14, which is 0. Okay, so therefore, the vector we've called C, which is 3, 2, 14, is perpendicular to A and B. That's very handy. So now we've got a way of finding a vector that's perpendicular to any two other vectors. Very handy, very useful. Okay, so if it's this question here, it's saying find a unit vector that's perpendicular to both of these vectors. Well, we've got a way of doing it. If we find the cross product of both of these vectors, we've got a vector which is perpendicular to both, but we're going to divide it by its length so that we get a unit vector. So we mustn't forget to divide by its length to turn it into a unit vector. Would help if I spelt length correctly. Right, so let's work out 4, 3, 2 cross 8, 3, 3. And the way we're going to be doing that is the determinant of that 3 by 3 matrix I, J, K, 4, 3, 2, 8, 3, 3. This is the quick way, rather than doing it directly. So the first element times by its minor, 3, 2, 3, 3, plus or minus, not plus, minus j times by its minor, which will be 4, 2, 8, 3, plus k times by its minor, which will be 4, 3, 8, 3. Right, so what does that give us? Starting with the first one, that's going to be 9, 3 times 3, minus 6, so that's 3, so that's going to be 3i. This is really quick this way, for 3i. Moving on to the next one, this will be 12 minus 16. 12 minus 16. So that would be minus 4, but then we've got the minus there, so then it makes it plus 4. Then the last one, we're going to have 12 minus 24. So 12 minus 24, that's minus 12. So minus 12 k. So this is a vector that's perpendicular to both, but we need to turn it into a unit vector. Okay, so unit vector is basically where we're going to take this vector and divide it by its length. So 1 over the square root of 3 squared plus 4 squared plus minus 12 squared of this vector 3i plus 4j minus 12k. So let's use our calculators and work out what that is. Let's get my calculator in the right mode for starts. So 3 squared, we're probably going to leave this as a third. 9 plus 16 plus 144. So that's root 167. Sorry, not root 167. Root 169, I put in 4 squared as 12. So that's going to be dividing by 13, yeah? So all of this here is basically 1 over root 169, not 1 root 7, so 1 over 13. So we can just stick 1 over 13 in front. So we can write it as 1/13 3i minus 4j minus 12k. Or if you want, you could write it as 3 over 13i minus 4 over 13j minus 12 over 13k. Yeah? So either one of those can be fine for the way that you write your answer. Yeah, and we'll just highlight those. So we've got a nice, really quick way of finding a vector that's perpendicular to any two other vectors. Okay, find the sine of the acute angle between these two vectors. So the first thing we're going to do is we're going to write down the definition of the cross product. We're going to rearrange it. So A cross B, length of A times the length of B times the sine of the angle between them times by this normal vector. Since we want to find the sine of the angle between them, it's this we want to make the subject. So the first thing that we'll do is we'll divide both sides by the length of A and the length of B. So that gives us sine theta times by this normal vector. Now since we want the acute angle, we want to do the modulus to ensure that sine theta is positive. Now if we do the modulus of both sides, there is a modulus rule that basically says that here, if we're going to do the modulus of that, it's the same as the modulus of this times by the modulus of this. Now since this is a unit vector, the length of a unit vector is 1, so we're going to end up multiplying by 1. So all of this will become the sine of the angle between them will equal, or the acute angle between them, A cross B divided by length of A times by the length of B. So let's start by working out the top part, which is A cross B. And in fact, there's actually another rule to do with modulus that says that I've got the modulus of the whole thing here. That can be written as the modulus of the top over the modulus of the bottom. So we can split it up like that. Anyway, A cross B, let's start with that first. So we're going to use the determinant method. So that's going to be the determinant of this, ijk, and our coefficients are going to be 2, 1, 2, 2, 1, 2, 0, minus 3, 4. So that'll be I, 1, 2, minus 3, 4, minus j, and that will be 2, 2, 0, 4, plus k, and that will be 2, 1, 0, minus 3. So this is just for the top part, this is just for the cross product. Right, so if we work that out, so work this out here, that'll be give us 4 minus 6, so that'll give us 10. So 10i. Moving on to the next one, this will be 8 minus nothing, so that'll be minus 8j. Then moving on to this one, this will be minus 6, take away nothing, so that'll be minus 6k. 6k. Now we're going to need the length of this, because the length of this is going to go here. So we do need to find the length of it. So that will be the square root of 10 squared plus negative 8 squared plus negative 6 squared. So that means the length of A cross B on a modulus, the size of A cross B, is going to be square root. Now what have we got? 100 plus 64 plus 36, so root 200, which is 10 root 2. So this will be 10 root 2, square root 200. So that goes at the top. At the bottom we want the length of A and the length of B. So the length of A is going to be 2 squared plus 1 squared plus 2 squared. So what's that? Root 4, 8, 9, root 9, which is 3. Then we want the length of B. So that's going to be just two numbers there, minus 3 squared plus 4 squared. You could put plus 0 squared if you wanted to. So that's going to be 9 plus 16, which is, I do not know why I'm getting a calculator for, 25, root 25. I don't need a calculator for this, which is 5. So now the sine of the angle between them is going to be the length of the cross product, so that's 10 root 2 over length of A3 times by 5. Let's see if my calculator simplifies that. So 10 root 2, divide that by 15, and I get 2 root 2 over 3 as a final answer if I simplify it. So 2 root 2 over 3 for my final answer there. So let's just highlight that. Okay, you should now be able to do exercise 1A on pages 5 to 6, and there's a number of things that we need to write down for a recap here, because there's lots of different things that we've done. So we'll start off by writing down that the definition of this cross product is length of A times by length of B times by sine of the angle between them times by this normal vector. Also that A cross B is not equal to B cross A, but A cross B is equal to negative B cross A. If A and B are parallel, then the cross product is 0, so A cross B equals 0 if A and B are parallel. If we have vector A equals A1, A2, A3, and vector B is B1, B2, B3, then we can use determinants to work out the cross product. So that will be this, I, J, K, A1, A2, A3, B1, B2, B3, like this. Okay, so it's going to be I times by its minor. Actually, let me just pause and write the rest out. We also have some other results for the cross product of the unit vectors I, J and K. Okay, so we've already mentioned that if they're parallel, that their cross product is 0, and it's the 0 vector, so it should be underlined. So I'll just do these here. And K as well. And then what I'm going to do is right underneath, I'll pause it and write down all the other results for the cross products of combinations of I, J and K. And lastly, when you want to find the sine of the acute angle between the two vectors A and B, it's going to be this. So you need to find the length of the cross product between them and divide that by the length of each of the two vectors, and that will give you the sine of the angle between them. And remember, this will give you the acute angle.